You walk into a museum, modern laser cutters, CNC machines, computer-guided precision instruments displayed like ancient relics. Every docent tells you the same story. We are the pinnacle of technological advancement. Our tools are the best humanity has ever made. And then you find a photograph. Göbekli Tepe, 11,500 years old, stone pillars weighing 50 metric tons, 5.5 meters tall, carved without metal, erected by people who supposedly had no writing, no wheels, no domesticated animals. The central pillars of enclosure D align to form a nearly perfect equilateral triangle with enclosures B and C. Not close, perfect. Measured by researchers Gil Hakle and Avi Gopher from Tel Aviv University in a study published in the Journal of Cambridge Archaeological in 2020. They used computer algorithms to trace the architectural planning. 3 enclosures, 3 center points, 1 triangle. Sides match within measurement error. This was not accident. This was design. Hunter-gatherers who had not yet invented farming were using geometric principles that would not appear in documented human knowledge for another 7,000 years. Also, comment from which city you're hearing this from. Also, this script is researched and factual, using sources from Science Advances Journal published January 21st, 2026, reporting on the oldest elephant bone tool discovered in Europe by Simon Parfait and Sylvia Bello from University College London and the Natural History Museum London, and the Journal of Ancient Egyptian Architecture, where Glenn Dash published his Fall Equinox Alignment Theory in 2017. These are peer-reviewed academic sources documenting prehistoric precision that challenges modern replication. Now back to the information. Excavations led by the German Archaeological Institute beginning in 1995 revealed circular enclosures with massive T-shaped pillars. The central pillars of enclosure D measure 5.5 meters high. Weight estimates range from 8 to 10 metric tons each. Surrounding pillars reach 4 meters. The limestone was quarried from the bedrock directly adjacent to the structures. Distance from quarry to placement range from 100 to 500 meters maximum. Not a mystery. The mystery is the cuts. Flinders Petrie standards of measurement precision, which set archaeological survey benchmarks in 1883, would place these pillars among structures requiring theodolite-level planning. Enclosure D contains Pillar 43, known for its relief carvings of animals. 55 individual creatures carved in a space 2.15 meters high and 0.94 meters wide. The shaft width matches within millimeters across the height. No widening, no narrowing. Controlled vertical surfaces executed with stone tools on limestone. Pillar 18 and Pillar 19. In the same enclosure, show astronomical function verified in a 2025 study examining shadow patterns. The grooves cut into the upper sections of these pillars align with winter solstice, sunrise, and equinox positions, as they would have appeared in 9,500 BCE. 7 birds, carved on Pillar 18's pedestal, correspond to the movement of Pillar 19's shadow across those dates. This was calculation fixed in stone. The site was deliberately buried around 8,200 BCE, backfilled with debris and abandoned. Every pillar standing when they covered it. Weight 131 metric tons, transported from a quarry approximately 10 kilometers away. The H-blocks, named for their shape, display precision that Jean-Pierre Protzen and Stella Nair documented in their architectural study published through Cambridge University Press. They conducted the first professional field analysis of Tiwanaku's stonework. Their conclusion states that to obtain the smooth finishes, the perfectly planar faces, an exact interior and exterior right angles on the finely dressed stones, the builders resorted to techniques unknown to the Incas and unknown to us at this time. Sharp 90-degree interior angles observed on decorative motifs could not have been made with hammerstones. The pounding technique, standard for ancient Andean masonry, produces rounded interior angles. Puma Punku's angles are crisp. The joints between blocks measure 1 to 1.5 millimeters where mortar exists. Many joints have no mortar. The blocks interlock. A single piece of paper will not fit between stones in multiple locations documented by site surveys. Some blocks show 6 millimeter diameter drill holes, spaced with identical intervals along precision-cut grooves. The holes are perfectly cylindrical, depth consistent, spacing uniform. Andesite has a Mohs hardness of 6.5 to 7. Bronze, the hardest metal available to Tiwanaku culture, measures 3.5 to 4. Copper reaches 2.5 to 3. The cutting exceeds the tool material hardness. Stella Nair's experimental archaeology attempted replication using stone blades, flakes, and thin chisels made from flint, agate, jasper, obsidian, greywacke, quartzite, and hematite. She succeeded in carving an 8-inch half-cross design over extended time. The techniques work. The scale and speed required for Puma Punku's construction remain unexplained. 150 blocks scattered across the site, each one cut with the same precision. Mass production of custom-fit megalithic components 1,400 years ago. Measurements taken by the ancient Tiwanaku project documenting block dimensions and tolerances with modern survey equipment. Now back to the information. Average weight, 2.5 metric tons. Some granite blocks in the King's Chamber weigh 80 metric tons. The base forms a square. Each side runs within 20 centimeters of the others. The deviation is 0.08%. The angles are 90 degrees within 4 minutes of arc. Glenn Dash, engineer and founder of the Glenn Dash Foundation for Archaeological Research, published analysis in the Journal of Ancient Egyptian Architecture in 2017, showing the pyramid aligns to cardinal directions with accuracy better than 4 minutes of arc, 1/15 of 1 degree. The alignment is slightly counterclockwise from true north, 3.4 arc minutes off. Karen Spence from the University of Cambridge demonstrated in a 2000 study published in Nature that the pyramid's orientation matches celestial alignments available in 2467 BCE using the stars Kochab and Mizar as reference points. The precision is 1 millimeter per meter on the base level. Flinders, Petrie's 1883 survey, still referenced today, measured the internal chambers with theodolite precision. The King's Chamber granite blocks fit with joints measuring 0.5 millimeters. The chamber walls are vertical within 2 millimeters over the full height. The descending passage runs at 26 degrees 14 minutes. The angle holds within 6 minutes of arc over 100 meters of tunnel. The Grand Gallery ascends at 26 degrees with corbelled walls that rise 8.6 meters. Each corbel projects 3 centimeters beyond the one below. 7 corbels. Perfect mathematical progression. The chamber alignment faces magnetic north with a degree of precision that requires astronomical observation and geometric calculation before construction begins. Stone blocks positioned before the surveying tool existed, before the blueprint, before the metal tools that would make such cutting practical appeared in the archaeological record for Egypt. Construction phases from 3000 BCE to 1600 BCE. The Sarsen stone circle, the visible ring, erected around 2500 BCE. Sarsen stones transported from Marlborough Downs, 25 kilometers north. Blue stones from Preseli Hills in Wales, 240 kilometers away. The largest sarsen weighs 25 metric tons. The circle diameter measures 29.5 meters. 30 sarsen uprights with 30 lintels forming a continuous ring. Each upright averages 4.1 meters high, 2.1 meters wide, 1.1 meters thick. The spacing between uprights averages 1.04 meters. Variation across the circle is 0.05 meters maximum. Alexander Thom's surveys in the 1970s identified a standard measurement unit he termed the megalithic yard, 0.829 meters. The Sarsen circle uses this unit in the spacing and positioning of stones. The Sarsen uprights are placed with precision that puts each stone less than 3 inches out of position across the 97.5-foot diameter. Gerald Hawkins used an IBM computer in 1963 to analyze 165 significant features. He found alignments to summer solstice sunrise, winter solstice sunset, and 18 lunar positions. The station stones, numbered 91, 92, 93, and 94, form a rectangle. The long axis measures 300 feet. Only at latitude, 51 degrees, 10 minutes, 44 seconds north do the solar and lunar alignments occur at right angles. 50 kilometers north or south, and the rectangle cannot be set out with these alignments. The builders chose this location for its geometric relationship to celestial mechanics. The Aubrey holes, 56 chalk-filled pits dug around the inner bank, are spaced at precisely regular intervals round a circle 285 feet in diameter. The lunar cycle of 27.3 days can be tracked by moving a marker 2 holes per day to complete the circuit in 28 days. This is calendar architecture. The summer solstice sunrise, viewed from the center of the stone circle, passes directly over the heel stone. The alignment worked in 2500 BCE and still functions today, accounting for the slow drift in Earth's axial precession. William Stuckley documented this alignment in 1720. The precision required astronomical observation spanning decades to establish the solstice position accurately enough to fix it in stone. The walls zigzag in a pattern that creates structural strength, while using fewer stones than a straight defensive wall. The largest limestone blocks weigh 120 metric tons minimum. Some estimates reach 200 metric tons. Transport distance from Rumikolka quarry, 35 kilometers. The precision comes in the fitting. Pedro Cieza de Leon documented in 1550 that stones were so large and thick, it seemed impossible that human hands could have set them in place. The joints were so close together and so well fitted that the point of a pin could not have been inserted. Modern surveys confirm this. A credit card, 0.76 millimeters thick, will not fit between many stones. The blocks are polygonal, 12 angles, 24 angles, each surface curved and shaped to interlock with adjacent stones in 3 dimensions. No 2 blocks have the same shape. Each one is custom cut to fit its specific position. The blocks show concave and convex surfaces that mate perfectly. The technique creates a jigsaw puzzle in stone. The walls lean slightly inward. The angle provides stability against seismic activity. The Andes are among the most seismically active regions on Earth. Cusco experiences regular earthquakes. Spanish colonial buildings built with European masonry techniques collapsed in earthquakes that left Sacsayhuaman standing. The 1865 earthquake destroyed much of Cusco. Sacsayhuaman remained intact. The 1950 earthquake, intact. The technique demonstrates understanding of seismic engineering centuries before the field existed. The trapezoidal doorways and windows distribute stress. The irregular stone shapes prevent uniform fault lines. The interlocking joints allow movement without collapse. Each stone can shift millimeters during ground motion and resettle into its original position. The physics work. The execution required no iron tools. The Inca used bronze implements with Mohs hardness below 5 working limestone and andesite with hardness 6 to 7. The cutting required abrasion techniques, hours of rubbing with harder stone and sand to shape surfaces. Contemporary mason Roger Hopkins attempted replication using similar tools in 1998. He achieved rough shaping. The precision matching multiple three-dimensional curves between adjacent stones took him weeks per stone at reduced scale. Sacsayhuaman contains thousands of such stones. Construction spanned less than 100 years. 20,000 workers using the MITI labor system. The mathematics says 4 person-years minimum per large block, including quarrying, transport, shaping, and placement. The largest blocks alone would consume 800 person-years of labor. The fortress required coordinated effort beyond the scale of documented ancient construction projects. 2000 BCE to 300 BCE construction, spanning 1700 years. The hypostyle hall, built under Seti Lorm and Rameses around 1300 BCE, contains 134 sandstone columns. The central 12 columns reach 21 meters high. 122 smaller columns stand 15 meters. Each column has a diameter exceeding 3 meters. The columns are arranged in 16 rows. The alignment is precise. British astronomer Sir Norman Lockyer published analysis in The Dawn of Astronomy in 1894, showing the temple's central axis aligns with winter solstice sunrise. At dawn on the winter solstice in 1400 BCE, the temple's construction period, sunlight would shine through the entire length of the central hall directly into the inner sanctuary. The beam would strike a statue of Ra for approximately 5 minutes. The alignment required understanding of the sun's annual declination and the exact degree of axial tilt. The columns support roof blocks weighing 70 metric tons. The capitals, the decorated tops of columns, weigh additional tons. Each capital is carved from a single block. The papyrus bundle capitals on the central columns show detail work requiring months of skilled carving per column. The reliefs covering the walls depict campaigns and religious ceremonies. The carving extends to the ceiling blocks, every surface utilized. The engineering challenge is the roof load distribution, 70 metric tons supported on columns with 3-meter diameters. The blocks span gaps between columns exceeding 5 meters. The sandstone has compressive strength around 30 megapascals. The load calculations work but leave minimal safety margins. Modern engineering would add reinforcement. The ancient builders relied on precise column placement and load distribution through the stone structure. The roof has stood for 3,300 years. The columns show no buckling, no failure. The foundation work required to support this load on Nile sediment demanded accurate surveying to ensure level surfaces. A column out of plumb by 2 degrees would concentrate load asymmetrically and cause structural failure. The temple survives intact. The Limanek western end curves to form a partial stone circle enclosure, diameter 100 meters. The stones decrease in height from west to east. The largest stones stand 4 meters at the western end. The eastern terminal stones measure under 1 meter. The decrease follows a mathematical progression. The rows run parallel with spacing that varies less than 1 meter across the full length. Alexander Thom surveyed the site in 1972 and identified the megalithic yard in the spacing. The alignment azimuth measures 57 degrees east of north. The direction corresponds to summer solstice sunrise, as seen from this latitude in 4000 BCE, accounting for changes in Earth's obliquity. The Licurmario alignment north of Menec contains 1,029 menhirs in 10 rows running 1,120 meters. The Licurmario stones also decrease from west to east. The rows are parallel. Both alignments share the same orientation. The consistency suggests coordinated planning. The Kurleskin alignment east of Kurmario contains 555 stones in 13 rows spanning 880 meters. Same orientation, same progressive height decrease. The 3 alignments form a connected complex stretching over 4 kilometers. The construction required moving and erecting 3,674 stones. Average weight, 5 metric tons. Largest stones exceed 20 metric tons. The parallel rows maintain spacing tolerance of 0.2 meters across distances exceeding 1,000 meters. The astronomical alignment holds across all 3 sites. The precision indicates surveying capability and celestial observation before metallurgy. Stone tools, Rope. Rollers. 4,000 years of weather. The rows are still parallel. Tons. It was transported from quarry to platform 11 kilometers. The statues rest on ahu, ceremonial platforms built from precisely fitted basalt blocks. Ahu Tongariki stretches 220 meters and holds 15 moai. The platform blocks weigh multiple tons. The joints between blocks are tight. The platforms are level. The moai were transported across the island using rope and wooden sledges or rollers. Experimental archaeology by Terry Hunt and Carl Lipo in 2011 demonstrated that teams of 15 people could move a 3 metric ton moai replica using ropes in a walking motion. The technique requires the statue to be shaped with a center of gravity that allows controlled movement. The ratio of height to base width must fall within a specific range. The Rapa Nui carved this ratio into 800 moai. The consistency indicates standardized design principles. Each moai is individual in facial features, but shares proportions with all others. The standardization enabled the transport method. The statues were erected on platforms using ramps and levers. Once vertical, the moai had to be positioned precisely on the platform. The feet rest on shaped base stones. The connection between feet and platform secures the statue. The precision required in shaping both the statue's feet and the platform stones determines whether the moai stands or falls. Ahu Tongariki's 15 moai, each weighing between 30 and 40 metric tons, stand in a row with spacing that creates a visual effect from distance. The Rapa Nui positioned them for sightlines from the village. The engineering required to erect 82 metric tons of carved stone on a platform without overbalancing, or cracking the base demanded calculation. One miscalculation and Perot would have shattered. It stands intact. The main chamber features carved columns and lintels cut from solid rock. The ceiling shows a relief pattern mimicking corbelled masonry. The carving is relief. The ceiling is solid rock. They carved away material to create the appearance of individual blocks. The oracle room contains an acoustic anomaly. Speech at certain frequencies resonates throughout the chamber with unusual volume. The effect works for male voices around 100 Hz. The chamber dimensions create resonance at this specific frequency. Whether the effect was designed or discovered accidentally cannot be determined. The existence was documented in modern acoustic studies and is reproducible. The builders carved this space with stone and bronze tools. The excavation of 11 meters of limestone using hand tools required years of labor. The chambers show smooth walls. The ceiling height maintains consistency throughout rooms. The doorways are rectangular with precise corners. The oldest known underground temple complex carved 3,600 years ago. The effort to create this structure when humans were transitioning from stone to metal tools demonstrates organizational capacity and labor coordination. The site was discovered in 1902 during construction work. The workers broke through the roof of the upper level. 6,500 years of use and burial. The chambers remained intact. The complex housed 20,000 people with livestock and food storage. The structure includes ventilation shafts running the full depth. The shafts are vertical. 52 total shafts providing air circulation to all levels. The largest shaft has diameter 3 meters and depth 70 meters. The shaft alignment required surveying from surface to maintain vertical orientation through 18 levels of excavation. Deviation from vertical would cause shafts to intersect chambers on lower levels. The shafts run true. The complex contains wells providing water. The wells reach depths exceeding 50 meters. Water sources are located on multiple levels, indicating the builders knew the aquifer depth before excavation. Each level connects via narrow tunnels that could be sealed with circular stone doors. The doors are cut from single blocks. Diameter 1 to 1.5 meters. Thickness 0.5 meters. Weight approximately 500 kilograms. The doors roll on pivot pins carved into the floor. The door fits the tunnel opening precisely. The seal prevents passage. Each door could be operated by one person from the defensive side. The engineering required to hang a 500-kilogram stone door on a pivot and allow one person to move it demonstrates understanding of mechanical advantage and friction reduction. The surface is carved smooth on the pivot points. The lower levels include spaces for wine and oil production, religious chambers, and communal meeting areas. The excavation removed thousands of cubic meters of volcanic rock. The material was hauled up narrow tunnels to the surface. The labor scale rivals mining operations. This was habitation excavation completed before recorded history in this region. The Phrygian civilization that occupied the site left minimal written records. The engineering exists, the documentation does not. The passage measures 19 meters long, 1 meter wide, and increases in height from 1.5 meters at the entrance to 3 meters at the chamber. The chamber is cruciform. The main chamber has 3 recesses forming a cross shape. The ceiling is corbelled dome rising 6 meters above floor level. The corbelling uses overlapping stones to create a watertight seal. The interior has remained dry for 5,000 years. The roof box above the entrance admits sunlight on winter solstice. At dawn on December 21st, sunlight enters the roof box, travels down the passage, and illuminates the central chamber for 17 minutes. The alignment requires the passage azimuth to match winter solstice sunrise at 53 degrees north latitude. The accuracy is within 1 degree. The passage slopes upward at a gradient that directs the light beam. The gradient is 4%. The 17-minute illumination window proves the alignment was deliberate. Random orientation would not produce this effect. The exterior mound has diameter 85 meters, height 13.5 meters. The mound is built from layers of stone and turf. The exterior face is white quartz. The quartz was transported from Wicklow Mountains 80 kilometers south. The entrance curbstone weighs 5 metric tons and measures 3.2 meters long. The surface is carved with triple spiral motifs and lozenges. The carving precision is notable. The spirals are symmetrical. The lines are uniform depth. Stone carving 5,200 years ago producing geometric art. The monument required surveying to establish the solar alignment, engineering to build the core-belled chamber, and coordination to transport materials over long distances. Hunter-gatherers building monumental architecture with astronomical function. The sanctuaries are parallel chambers running the depth of the temple. Each sanctuary measures 2.5 meters wide. The walls between sanctuaries are load-bearing. The interior chambers feature columns and carved reliefs. The column alignment creates sight lines through multiple rooms to the sanctuaries. The relief carving covers all wall surfaces. The Abydos king list carved on the wall documents 76 pharaohs from Narmer to Rameses I. The hieroglyphs are carved in raised relief. Each symbol is approximately 5 centimeters high. The symbols are uniform across the entire list. The spacing between cartouches is consistent. The list runs 7 meters horizontally. The carving precision indicates template use, or master carvers maintaining standards across the work. The temple ceiling blocks are sandstone weighing tens of metric tons. The blocks span chamber widths exceeding 5 meters. The ceiling remains level. The chambers are dark. The relief carving was executed in low light conditions or by firelight. The detail level in some reliefs shows carving precision of 1 millimeter. The Osirian, a separate structure behind the main temple, is built from red granite blocks. The blocks weigh up to 100 metric tons. The granite was transported from Aswan, 700 kilometers south. The Osirian construction technique differs from the main temple. The blocks are placed without mortar. The joints are tight. The water feature in the center of the Osirian is engineered with channels and basins. The structure floods intentionally during high Nile. The water level in the basins rises and falls with the river. The hydraulic connection required surveying the aquifer level and engineering the foundation to allow controlled flooding. The Osirian was built before the Seti temple. The construction date is uncertain, but predates 1300 BCE. The megalithic building techniques and astronomical alignments appear across cultures and millennia without documented technological transfer. Astronomical alignments, precision fitting, engineering complexity beyond the documented tool technologies of their construction periods. The consistency appears across continents. Göbekli Tepe in Turkey, Pumapunku in Bolivia, Stonehenge in England, Sacsayhuaman in Peru, Easter Island, Malta, Egypt, France, Ireland. The construction methods vary. The precision standards are similar. Modern attempts at replication using proposed ancient techniques achieve the basic tasks: moving large stones, shaping surfaces, carving reliefs. The precision achieved in ancient structures consistently exceeds experimental archaeology results. The joints at Pumapunku and Sacsayhuaman are tighter than modern masonwork using diamond tools. The astronomical alignments at Stonehenge and Newgrange function across millennia of axial precession. The geometric planning at Göbekli Tepe shows mathematical principles documented thousands of years later. The pyramid base measurements demonstrate surveying accuracy requiring instruments not present in the archaeological record. Writing systems appeared late in human development. Engineering capability appeared early. The archaeological record shows stone tools dating to 3 million years ago. Controlled fire 1 million years ago. Modern humans emerged 300,000 years ago. Behavioral modernity appeared 50,000 years ago. Agriculture began 10,000 years ago. Writing appeared 5,000 years ago. The gap between behavioral modernity and writing is 45,000 years. The gap between agriculture and writing is 5,000 years. Göbekli Tepe was built 6,400 years before writing appeared in that region. The builders possessed knowledge not recorded until millennia after their structures were complete. The same pattern holds across all 12 structures. The construction preceded the documentation of the methods. The precision existed before the tools that should have been required. The written record captured the products, but not the process. When Herodotus visited Egypt in 450 BCE, the pyramids were already 2,000 years old. The construction methods were unknown to his guides. When Spanish conquistadors reached Sacsayhuaman in 1533 CE, the Inca attributed the construction to earlier peoples. The techniques were already lost. The writing appeared after the peak construction period. The records document results, not methods. The ancient error is measurably larger than modern precision. But 4 minutes of arc over 230 meters produces 5 centimeter deviation. The human eye cannot reliably detect 5 centimeter error across 230 meter distance. The ancient precision meets the limit of unaided human visual acuity. The tools enhance precision. They did not create the capability. The capability existed in human spatial reasoning and mechanical skill. The evidence is the structures. 887 moai carved to standardized proportions. 3,674 standing stones in parallel rows across 4 kilometers. 134 columns, supporting 70 metric ton roof blocks for 3,300 years. 50-ton pillars arranged in geometric patterns 11,500 years ago. The precision is documented. The methods are inferred. The capability is proven by the existence of the structures themselves. 76 pharaohs documented. The list omits several pharaohs known from other sources. Hatshepsut is absent. The female pharaoh who ruled 21 years. Akhenaten is absent. The heretic pharaoh who moved the capital and changed the religion. The list preserves one version of history. Other versions existed and were suppressed. The same pattern applies to technical knowledge. The techniques that built Sacsayhuaman were not written down. The Spanish saw the structures and marveled, but did not learn the methods. The Inca themselves attributed the work to earlier cultures. The knowledge was already fragmentary. The conquistadors dismantled Sacsayhuaman to build colonial Cusco. They used the smaller stones. The megaliths remained because they were too heavy to move even with Spanish technology. The stones that proved impossible for 16th century Europeans to transport had been moved and precisely placed by 15th century Inca with more primitive documented tools. The Quilque built on the location 500 years before the Inca fortress. The megalithic construction techniques may have originated with the Quilque. The Inca inherited the site and the knowledge. When the Spanish arrived, the direct transmission had been disrupted. The engineering knowledge survived in the structures, but not in complete documentation. The same pattern at Göbekli Tepe. The site was deliberately buried around 8,200 BCE. The enclosures were filled with debris and covered. The pillars remained standing under the fill. The burial preserved the structures for 11 millennia. Modern excavation, beginning in 1995, revealed the site. The prehistoric architects created monuments that functioned as astronomical calendars and geometric demonstrations. Then they buried them. The reason remains unknown. The action preserved the evidence. The mathematical proof came later. The pattern repeats. The Temple of Karnak's solstice alignment, the Newgrange winter solstice illumination, the Great Pyramid's cardinal orientation, the Karnak stone row's astronomical direction. Each structure demonstrates applied knowledge of geometry, astronomy, and engineering. The theoretical framework was documented millennia after the practical application. The archaeological record shows human advancement as nonlinear. Technology improved, knowledge accumulated, skills were lost, rediscovered, lost again. The Bronze Age collapse around 1200 BCE destroyed civilizations across the Mediterranean. Writing disappeared from Greece for 400 years. The Mycenaean palaces fell, the population declined, trade networks collapsed. When writing returned, it was a different system. The linear B script was forgotten. The Greek alphabet emerged from Phoenician letters. The intervening centuries left minimal records, the same pattern at smaller scales throughout history. Knowledge transmission relies on continuity, master to apprentice, teacher to student, writer to reader. When the transmission breaks, knowledge is lost. The structures remain as evidence of what was known. The methods must be reconstructed from the products. Modern engineering applies documented principles. Finite element analysis calculates stress distribution. Computer models predict structural behavior. Materials science quantifies material properties. The analysis can examine ancient structures and determine they should work. The core-belled ceiling at Newgrange distributes load properly. The column spacing at Karnak maintains safe stress levels. The zigzag walls at Sacsayhuaman provide earthquake resistance. The modern analysis confirms the ancient engineering was sound. The question is how the ancient engineers knew the principles worked without the mathematical framework that documents why they work. The answer is experimentation, observation, trial and correction across generations. The Rapa Nui carved 800 moai before they stopped. The early moai are cruder. The later ones show refinement. The learning occurred through practice, the same pattern at every site. The techniques improved over time. The construction sequence shows increasing sophistication. The final products represent generations of accumulated knowledge. CNC machining can cut stone to tolerances of 0.01 millimeters. The ancient precision at Pumapunku is 1 to 1.5 millimeters. CNC achieves 100 times greater precision. But CNC operates continuously. A CNC machine cuts 24 hours per day. The ancient mason worked 8 to 12 hours per day. The CNC machine requires electricity, computers, and replacement carbide bits. The ancient mason required food, stone hammers, and copper chisels. The energy input differs by orders of magnitude. The precision difference is 2 orders of magnitude. The efficiency comparison favors the ancient method when energy cost is considered. The ancient precision was sufficient for structural integrity and aesthetic effect. The modern precision exceeds functional requirements for most applications. The ancient builders achieved exactly the precision needed. Not less, not more. That level of precision required understanding what precision was necessary. Sacsayhuaman uses polygonal interlocking stones. Stonehenge uses post and lintel trilithons. The methods differ. The precision standards are similar. The pattern suggests precision was valued across cultures. The reasons vary. Religious significance, astronomical function, defensive strength, aesthetic effect. The execution in each case required sustained effort and skilled labor. The coordination of 20,000 workers at Sacsayhuaman. The transport of bluestones 240 kilometers to Stonehenge. The carving of 800 moai on Easter Island. The excavation of 18 levels at Derinkuyu. Each project represents decades or centuries of organized labor. The precision was not accident, it was goal. The tight joints resist water intrusion. The astronomical alignments maintain function across millennia. The geometric planning distributes loads effectively. The earthquake-resistant techniques protect against seismic destruction. The ancient builders designed for permanence. The precision was means, the permanence was end. Modern construction uses planned obsolescence. Buildings are designed for 50 to 100-year lifespans. The economic model requires replacement. The ancient model required endurance. The precision served the goal. The goal produced the precision. The spacing accuracy required preliminary surveying with the guides in place. The marks confirm the construction sequence and validate the precision was intentional. Small discoveries continue. Each one adds detail to the picture. The picture shows human capability exceeded documented tool technology across millennia and continents. The knowledge existed. The transmission was incomplete. The record preserved the products, but not the full process. The research continues. New sites are discovered. Göbekli Tepe excavation has revealed less than 5% of the site. Additional enclosures remain buried. Karahan Tepe, 15 kilometers east of Göbekli Tepe, shows similar T-shaped pillars. Excavation began in 2020. The site may be contemporary with Göbekli Tepe or earlier. Each new discovery adds data. The pattern holds: large stones, precise placement, astronomical alignments. Geometric planning, the human capability to engineer monumental structures with primitive tools. The knowledge existed before the tools that should have been required. The engineer experimenting with load distribution. The worker learning to move large stones efficiently. The accumulated knowledge of 100 generations applied to a single project. The precision came from practice. The structures came from precision. The mystery is not that they exist. The mystery is that the knowledge was not preserved in writing until millennia after the peak achievement. The structures stand as evidence. The methods must be reconstructed. The capability is proven.